morning, good afternoon, wherever you are in your day. As always, thank you for choosing to make chemistry part of your day. A lot of times in Chem 101 or general chemistry, they'll start talking about reactions and solution chemistry together, and this is by design. For two molecules to react, they actually have to be able to bump into each other. And not only that, then they have to be able to move. So we're talking about liquids, we're talking about gases. Gases are a little bit harder to work with from a practical standpoint. If you create gas, you could accidentally have an explosion. If you consume gas, you could accidentally have an implosion. So for a lot of reasons, when we talk about reactions, when we introduce this idea, a lot of it's in water, a lot of it's aqueous, a lot of it's solution chemistry. And generally, the textbooks divide this into three categories: precipitation reactions, acid-base reactions, and redox reactions. And there's going to be a series of videos on all of these. I think there will be 3 on redox, 1 or 2 on acid, probably about 3 on precipitation reactions. But I just want to do a quick intro overview. You could argue this isn't necessary, but for everyone that just wants to see them all at once and get their head around the idea, here you go. All right, so in sequence, precipitation reactions. So when it's precipitating outside, something is falling out of the sky. Could be snow, could be sleet, could be rain, could be puppies. Watch out for them, they're heavy. You don't want them to hit you in the head. Need a good umbrella for those days. But something's falling out of the sky. So precipitation reaction is going to be the same thing. Something is falling out of solution. So your solutions look clear. And typically, so again, going back to this liquid theme, we're talking about something that's aqueous. So everything on the left is going to be aqueous. And then something's going to fall out of it. That thing that falls out of it is going to be a solid. So you're going to know a precipitation reaction when you see one, when everything on the left is an aqueous solution and something on the other side is a solid. So we're forming a solid. That solid itself is called the precipitate. And the reaction itself is a precipitation reaction, forming the precipitate. And then there can be other products as well. But that's what you're looking for. Aqueous goes to solid. And again, from a lab standpoint, you would see something clear turn cloudy when you mix the two solutions together. So this would be a clear colorless solution, as with this. When you pour the two together, you'd see a white, it would almost look like milk at first, and then eventually you'd see white particulate matter settle to the bottom. All right, acid-base reactions. And for those of you that know chemistry, and I know some people probably look at these videos not in the class, this is a way oversimplification, and I'm good with it. So as far as Chem 101 goes, an acid is something that starts with H. If I put an H out front, if the textbook puts an H out front, that means it's an acid. Likewise, we're going to overly simplify a base, and typically it's going to be something that ends in OH. We do deal a little bit with NH3 as an example of what will come in Chem 102 as you continue with the curriculum. But for the most part, acids are going to be things that start in H. Bases will be things that end in OH, with the exception of NH3. And then typically what a book would say is they might call this a neutralization reaction, where we take a solution that's dangerous and acidic, dangerous and basic, we mix it together and we get salt water. We get a salt and water. In this case, we get sodium chloride, but you get some kind of ionic compound and you get water as a byproduct. What really makes it an acid-base reaction is the transfer of one hydrogen cation from the acid over to the base. So if you look at this, HCl is losing an H+, the OH gains that H+, so HOH becomes H2O, and that's the water, and the rest of this is just floating in solution. The third and final category is redox reactions, and this is electron transfer. So electrons are moving typically from like a metal to a nonmetal, for example, where the metal forms a cation and the nonmetal forms an anion, and that's consistent with what we talked about earlier in the semester. So let's take a very simple reaction. Magnesium ribbon, and I could have put oxygen here. We could just burn it in air, like those fireworks that make the big bang and the bright light. So we can magnesium ribbon, oxygen, chlorine, pick your favorite nonmetal, and they react to form a salt, magnesium salt, in this case magnesium chloride. Without having to know a lot of chemistry, these things are by themselves, and you notice I emphasized here that they have no charge. So that means they start with a charge of 0. Over here, we know, remember, chemistry is a happy, positive place. The first thing's always positive, last thing's always negative. Don't really have to know what the number is to understand the concept. Magnesium is going from no charge to a positive charge. Chlorine is going from no charge to a negative charge. And actually, we call this getting smaller or more negative. We call that being reduced. And this is oxidized. And those two words together form reduction, form redox. Reduction and oxidation. So this is reduction, this is oxidation. Again, we'll have videos that go into great depth on this. But you're going to see something change charge from the left side to the right side, a reactant side to the product side, and that's what makes it a redox reaction. One should go up and one should go down if things are written correctly. And that's all for the overview, and hopefully this helps you a little bit. Again, the individual videos will be much more helpful on these topics.